Hello. Thank you for joining us today. My name is Bill Shin. I'm a Principal Security Solution Architect for Amazon Web Services. Today we're covering compliance beyond the checkbox. We'll talk a little bit about what that means. But before we get started, I'd like to deal with some administrative details about the webinar. So on your screen, at any time, you can ask questions and answers, and the moderator, Paul Stamp of our security marketing team, will pick questions from the crowd and bring them to me at the end of the presentation for a Q&A forum. During the webinar, he'll also attempt to address questions that he can address directly. After the presentation, the slides and the recording will be made available through the webinar website. So let's get started. You've probably seen Amazon Web Services compliance and assurance programs before. We have numerous certifications and attestations by third parties. And so when we say moving beyond the checkbox, what we mean is instead of just looking at ISO 27001 as a logo or looking at FedRAMP as a logo, we want to take the next step, which is to help you build a compliant environment on top of Amazon Web Services. So while the controls and attestations and third-party assurances that we provide give you a sound foundation for how we operate the cloud, the security of our data centers, the risk management frameworks of our organization, and the controls that go into building a cloud solution for you. This presentation goes on to discuss more about how your portion of the shared responsibility model and how you can build a compliant environment on top of Amazon Web Services and do so in an automated fashion. First of all, a couple of examples of customers who've built compliant environments on top of Amazon Web Services. St. James Place is a large financial institution in the United Kingdom who needed a high level of data security to comply with a financial conduct authority. They chose Amazon Web Services because of the sound foundation of compliance and third-party attestations that we're able to provide able to run their business. They're able to double their capacity during tax season and contract it back down. So using the flexibility and scale of AWS, they're able to meet their compliance requirements as well as grow their business. Another example is Orion Health. Starting in 2013, Amazon Web Services started signing business associate agreements under HIPAA. And since then, we've had hundreds and hundreds and hundreds of customers join Amazon Web Services and start using our services to process protected health information. Orion Health is a specific software company that develops modern and creative solutions for healthcare. They had a need to build one of the largest health information exchanges in the country called CalIndex, and they partnered with AWS partner LogicWorks to build this solution. They selected Amazon Web Services because of the HIPAA compliance capabilities and the ability to architect on top of us in a HIPAA compliant way, using our services offered under the business associate agreement. This solution will actually grow to carry millions of personal health information records and to enable Orion Health to deliver interesting and personalized health medicine to customers of CalIndex. So you've probably seen this before. As you know, Amazon Web Services and you share the responsibility for security. So starting with the global infrastructure, we have availability zones around the world. And we have regions around the world. And within those regions, there's numerous availability zones. We also have edge locations to provide for content caching and distribution network. As we move up the stack, the foundation services, so compute, storage, database, and networking, provide you a solid foundation to build your solutions on. In many cases, we own the controls. So we own the controls of physical data centers, of the hypervisor, of how our organization works, and allow you to architect on top of us. The portion of responsibility that you control would include access to your operating systems, access to your applications, the security of your data in a database or how it flows through your applications, and the infrastructure that you choose to put on top of Amazon Web Services. So you can build interesting security services and proxy layers and mitigation controls and things in the infrastructure that would allow you to build on top of us. And again, your customer applications and content are your responsibility. So the security of the code that you launch into Amazon Web Services is still your responsibility. But we'll help you move beyond that, the simple checkbox of saying, well, data center controls or access control, and look at how you can compare compliance controls across the stack and use Amazon Web Services to implement some of those. So what this means for you is that you benefit from an environment built for the most security-sensitive organizations. What that means is that we have customers in every single vertical, in healthcare and financial services. We have customers in Europe that have data protection directive requirements. We have customers that serve government contracts that have FISMA requirements. And you're able to build your startup or your business or your enterprise on top of that strong foundation. We receive customer requirements, again, from around the world and across all those verticals, and we have to engineer to the highest level of security. And you also retain the flexibility, though. You retain the ability to define the right security controls for your workload. So if you require encryption, there's a variety of encryption solutions available to you. You can use our key management solution. You can bring your own keys and run those in AWS, or you can encrypt data outside of AWS and store it on the cloud. And again, you always have full ownership and control of your data. So for example, if you have a jurisdictional requirement to keep data in Europe, you can store data in the Frankfurt or Dublin region, and Amazon will never move that data outside of that region, and you retain full ownership and control of that data. So typical compliance domains. If you look on the left, the physical security, the data center operations, and the personnel in the data center, those become largely out of scope for you. We take care of those. So again, the things you would normally have to invest in and provide significant amount of oversight to, those are all covered under our third-party attestations, ISO 27001, the FedRAMP authorization to operate, and the NIST 853 controls that back that up, all very well address the physical security and data center operations of rack and stack and cabling and physical infrastructure, climate controls, and all the things you would normally have to look after in your own environment. Those things become essentially out of scope for you, and you're able to inherit those controls from our third-party attestations. Things that have a reduced scope would be disaster recovery, network security, things like change management, system security, asset management, and monitoring. Now, there's still a portion of those that belong to you inside your instances and your applications. So, for example, disaster recovery. We take care of recovering the buildings and the regions, and if an availability zone fails, traffic is rerouted so that other availability zones within a region can serve that traffic. But you have a portion of that responsibility that's still in your scope to back up your content and keep versions of that data available for your business and know which versions meet your RTO or RPO requirements. Network security, for example, we have protections in place to protect the aggregate of the cloud, to protect our service APIs and protect the bulk of our customers as a whole, and to protect our business. Network security, though, goes all the way up the stack. So specific rules for, say, a web application firewall that are very specific to your application, those are things you can implement inside of EC2 or VPC using web application firewalling and network security tiers and trust zones to divide your applications up in the way that you might in a traditional data center. Things like DMZs, you can architect inside of VPC and have those available to you to manage in your scope of network security. System security is another good example of reduced scope. Amazon Web Services manages the hypervisor. We patch the hypervisor, we keep it up to date, and we make sure it's secure so that the virtualized guests that run your operating systems are secure. But within that operating system, we don't have access to that operating system. So things like patching, things like host intrusion detection, and hardening the file system on the operating system are still your responsibility. Things like change management and asset management, again, reduced scope. You don't have as many assets. You don't have network switches and routers and racks and storage fabrics to maintain assets for. Those are all virtual objects within AWS. And change management is taking care of those things by us. But if you deploy your applications, you can focus your change management resources and efforts on protecting and controlling and limiting the impact of changes just to a smaller scope for the compliance folks to look after. So in terms of running a compliance program, the scope is drastically reduced, which means you're focusing your efforts on more high-value areas. And in those high-value areas, we give you tools to help. So things like application security and identity management, you can use services that are part of AWS. So key management service is a great example of an application service or application security where you have a tool that's a service API where you can use to encrypt content and get a full audit trail in KMS of each key that you use, or each time a master key controlled by the customer is used. Another example of encryption would be using CloudHSM, where you have the opportunity to have a dedicated hardware security module dedicated to you into your VPC, where we manage the availability of that device, but you have complete control over the cryptographic modules that would provide access to master keys. So those tools can help you concentrate on more important parts of your business, can help you reduce the scope of your compliance efforts. Identity management's a deep topic, and we could spend hours on this topic, but when you're building your assets in Amazon Web Services, the important thing is that you have identity and access management as a service as part of the AWS platform. And that service provides users, groups, and roles and policies that you can use to provide very fine-grained access to AWS resources. Identity management and identity and access management on AWS, though, is slightly different than access and identity into your applications and operating systems. In that case, you can bring your own Active Directory. You can use AWS Connected Directory to tie the use of AWS to your own AD. You can authenticate users into your own applications the same way you would with any single sign-on application, or custom authentication and authorization within your applications. But it's important to know that our identity and access management platform is providing access to AWS resources, and the tools it provides allow you to manage with very fine-grained access things like who can create a subnet, who can create a security group or a firewall rule, who can launch an instance into a particular region. So we give you very fine-grained tools and policies to help you do that. Data security, so lots of folks use us for volume storage or elastic block store, which is the block storage you would typically attach to an instance or server. You can have very fine-grained policies, again, on elastic block store, where who can copy content, who can copy or take a snapshot of that elastic block store. For S3, which is an object store, used for massive scaling of trillions of objects. You can have bucket policies and access control lists, which provide very fine-grained detail on who can access objects in a bucket. And again, that lets you concentrate on the right things. So as a compliance program, you're focusing on risk management to your business and to your organization. And meaning, if you reduce the scope or take things out of scope, you can use a much more prioritized effort on your risk register to look at the right things. Also, you can focus on things like application security and code reviews and incident response. So beyond the checkbox, we'll talk a little bit about what I call security cartography, which is, we'll dive into that in a second. We'll talk a little bit about automating evidence collection, and then how evidence can help measure reality. Let's get started there. So security cartography, or another term might be to think of this as like a Rosetta Stone. So most organizations or enterprises are based on either some kind of custom control framework. We have over 1 million active customers, and I spend a lot of time talking to them about how they can manage their own control framework on top of AWS. So in many cases, we see security questionnaires, or we have conversations with the customers about their control framework. And when you dig into the details, many of those custom control frameworks are based on some permutation of NIST 853 or ISO 27001 or some other permutation of control frameworks that end up giving them the control coverage that they want. What that means is that if you're trying to reduce the effort that goes into a compliance program and move kind of beyond the checkbox of just looking at certifications, you do this initial mapping exercise that a lot of companies will do. So if they have their own custom framework, they maybe have mapped in different control frameworks to build a set of controls they want to run in their organization. What we encourage our customers to do to reduce that scope is look at the controls, the attestations that we have attained. So if you are an organization based on ISO 27001, we also have that certification, and however you track your compliance efforts, whether that's in a governance, risk, and compliance tool or GRC system, or whether it's Excel or some other format for tracking compliance artifacts and knowing that you're compliant with something, mapping in our controls from our certifications into that system will help you reduce the scope and efforts to go into your audits. There, again, will be some controls that both of us operate. So access control is a good example. In ISO 27001, we have access control requirements that we're audited for. So that includes the access control of our staff to the systems that run and operate the cloud. But that doesn't include the scope of access to your operating systems or access to your applications running on top of us. So again, that reduces your scope, but allows you to have very similar controls and control objectives across your use of us as a cloud service provider, as well as within your applications. Another great tool is the Cloud Security Alliance control matrix. It's the newer version, 3.0.1 from the Cloud Security Alliance. It does include a great Rosetta Stone or a mapping in that matrix. It maps up their controls and the way that they define them with NIST 853, with ISO 27001, with HIPAA, PCI DSS 3.0, and includes quite a comprehensive mapping. So if you're not familiar with that, check it out. It's on the Cloud Security Alliance site, and you're able to use that so that if your organization is built around ISO 27001, or you have HIPAA security rule requirements, for example, but then you're using us as a cloud service provider who is accredited under, say, NIST 853, you're able to map up the controls so that you don't have to go gather evidence. One thing we're asked to complete a lot too, and the financial services industry has had this around for quite a while, is the shared assessment, shared information gathering tool. It's kind of the Uber questionnaire or questionnaire of questionnaires, and it includes a very comprehensive mapping to ISO 27001 as well. So typically large organizations have had their custom questionnaires or their custom due diligence process for security, and they send it around to all their vendors. And at one point, people realized they were all sort of sending the same shuffled up set of questions to each other all the time. So they came out with a shared information gathering tool, and it allows its several, many tabs in Excel of different questions, and it has a vendor or even you as an organization can complete that to sort of say, well, we're operating controls effectively in the following areas. And again, that maps to 27001. So the fact that Amazon Web Services has ISO 27001, eliminates a lot of the scope of what questions you may need to ask just because that mapping exists. So the last item on this slide sort of reminds me of a Bugs Bunny cartoon where Bugs Bunny plays the doctor and then a waiter and then a shopkeeper and confuses either Elmer Fudd or Yosemite Sam or somebody. But most of these controls have so much overlap that it almost looks like it's the same, in many cases, the same set of controls. If you look at NIST 853 Rev 4, Appendix H of that gigantic document includes security control mappings for 27001 and ISO 15408. It includes it both ways too. So the ISO 27001 mapping includes it from NIST to ISO and from ISO to NIST and back and forth. So customers that have built or enterprises who have built their controls around ISO 27001 can leverage the FedRAMP or NIST authorizations that we have and get that fine level of detail as well. And the controls have so much overlap between these different attestation frameworks that many times you solve the control or implement the control once, and you're able to reuse that control many times without having to go create more work for the IT teams or for the application teams to gather evidence and control artifacts. The other thing too is if you're building a business on top of us, or if you have upstream customers as a user of AWS, which is a very common use case where people build SaaS applications on top of us, or they've built consumer-facing websites, and you have due diligence requirements of your upstream customers. These same mapping exercises and what I would call kind of the Rosetta Stone of things applies, where you can leverage our attestations and you can get your own attestations and then prove that to your customers who are probably also giving you questionnaires and due diligence frameworks to kind of go through. So again, this is the example from NIST 853. I think it's deep in the document, but if you look on the left, you have the 853 controls, and these are just the general families. Things like access control. This is specifically the access control section, so segregation of duties, least privilege, and you can see that ISO 27001 has very similar controls in many ways across the board. They may be worded differently, but essentially the control objectives are very similar. Another great mapping or cartography experiment that NIST maintains is the NIST 800 or Special Publication 800-66, which maps the NIST 853 controls to the HIPAA security rule. So if you're a healthcare or someone processing protected health information, see, for example, the security management process control in HIPAA. And again, this appendix of the 866 document covers every single HIPAA control and then identifies which NIST security control mapping applies. So if you have a FedRAMP authorization, or if you have already attested to the effectiveness of your controls under FISMA, then operating protected health information workloads is drastically reduced in scope because many of the controls are the same. You still have all the privacy and a variety of other controls related to protected health information, but many of the things go away. This is around it's designed to help customers increase efficiency and really focus on the right things. Let's talk a little bit about automated evidence collection and how you can do that on Amazon Web Services. So we'll talk about three different kinds of asset management, or rather automated evidence collection. We'll do that in the scope of asset management, access control, and logging and monitoring. So again, it comes back to this mapping thing, right? So for asset management, it's the foundation of security because you cannot secure what you cannot manage. And if you don't know the assets that you're managing, it's very difficult to know the scope of what your attack surface is, or where your data is, or who should have access to those systems. And again, you can see the mapping here, right? So in ISO 27001, you have section A8, and then even more specifically in there, responsibility for assets. And that control is stated something to the effect of maintain a list of assets, thou shall keep track of your stuff. And in NIST 853 Rev 4, you have the configuration management section, and then more specifically, configuration management control 8, which requires you to maintain a component inventory. So with AWS, that becomes incredibly simple. First of all, you've got the control mapping there. So if you've got one certification or you've done one compliance effort, it satisfies many of the requirements of the other. And most control frameworks, even PCI, has a system component requirement. Most control attestations require you to maintain a tracking of assets so that you know what your scope is. With AWS, the accuracy of asset information is always correct. You have things like tags, and that you can tag. You give your assets and instances a name. You can tag and provide additional detail of a subnet or an elastic load balancer, and give similar naming conventions to those assets. So one perfect example is being able to put data classification on your assets, which allows you to filter and sort and query the environment as if it were a database, but be able to sort your environment by data classification. So let's say you have green, yellow, and red data classifications. And so whenever anyone launches an instance or say attaches a volume to an instance, if there's a requirement that that developer or engineer or IT operations person put a data classification on that system, it allows the compliance folks to quickly assess the state of their assets and say, okay, for all systems containing red data, we want to have the following controls in place. They should be on a non-routable subnet. They should be behind a load balancer. They should have the following security groups. Only certain people should have access to it. No management port should be available. The volume should be encrypted. It's kind of the foundation of knowing whether other controls are operating effectively. And being able to use tags and get metadata out of EC2 or out of VPC is an incredibly powerful tool for being able to move the needle and move beyond the checkbox in terms of automating these controls. So everything is just an API call away. It's very different from physical infrastructure where you've got to walk through a data center, or where when you install something in a data center, there has to be this manual effort to put it into a configuration management database. Instead of doing that, you can constantly query the environment for the state of your assets. And that includes all the metadata about assets, IP addresses, which could be used to source vulnerability scans. You could have even the roles in identity and access management are potentially assets themselves. So having a role or a group, you can constantly query the state of that asset. Another use case for asset management with tags is that when you know metadata about your network and your assets, you can make some very interesting security and compliance assessment kind of investigations, if you will, or ask questions of that content. So let's say you label your subnets as public or private, or internet routable or non-internet routable. You can make interesting queries of AWS to say, I want to query all of my EC2 systems with a red data classification and compare that to the subnet that they're on and look at the labels on those subnets, or look at the labels of the naming convention via the naming convention of my security groups. And I can say, I never want to have data or systems storing red data at rest in a non-routable or in a routable subnet that routes to the internet. I always want to have those in a private subnet, for example. So you become very, very efficient at identifying where the areas of focus might be for compliance. Access control is another one. Again, ISO 27001 or any compliance framework, if you dive into the details, include things like all the way down to A923 in ISO, which is management of privileged access. And it basically says you shall make decisions commensurate with policy to preserve a least access privilege model and make sure that only the right people have access to the right stuff. Access control family number 3 in NIST 853 says very similar controls. It's much, much more detailed than ISO. But again, basically stipulates that you shall enforce the least privilege policy. With AWS, again, this becomes about automating the attestation of that control. So not just looking at our third-party attestations or saying, well, my AWS use is tied to AD, or I have users, groups, and policies. You can really automate this in the review of this in an ongoing, continuous way. So once you've identified the users of AWS, and maybe you've tied the use of Amazon to your Active Directory through SAML assertions, or you've created identity and access management users for your engineers to use, knowing what entitlements they have is, again, it's simply a query away. You're able to not only look through the console, the management console, but use the APIs or the command line tools to query what people have access to. So every single thing you do in AWS is an API call. So when you launch an instance, when you create a firewall rule or a security group, whenever you attach a volume, whenever you create another role, every one of those things is an API call. and being able to express policy around who can make which API calls. Even if you're going through the console, it's ultimately hitting the API. But the policies you can apply in identity and access management allow you to express in extremely fine-grained what those actions are that users can take. And then from an audit perspective or from a compliance attestation perspective, you're able to query that information through the API. So the command line, for example, might include something like list roles, and then you get the list of roles and you get the list of policies attached to those roles. You can make another command line call to list the policies and get the details of those policies. And for a compliance audience, you might want that in a consistent format with the rest of your enterprise, whether that's a GRC tool, Excel, or screenshots, or whatever. Ideally, it's not screenshots, but the teams using AWS can easily automate the kind of the dumping of these reports and the review of those identity entitlements. And again, ideally, you only do that sort of once in bulk, and then you detect change and you use things like CloudTrail alarms and we'll talk a bit about that as well. You then detect configuration drift of those policies as you continue to use AWS, year over year. You know what changed, and you can review those individually. We also introduced a number of features in identity and access management that everyone should be aware of in the last couple of months. The way you used to manage identity and access management policies was you had users, groups, and roles, and you could attach policies to those individual objects. So you would have what were called inline policies, and the policies were applied to a user, applied to a group, or a role, and you couldn't share the policies across those different things. We introduced the concept of managed policies in the first part of this year, and those managed policies exist outside of the users, groups, and roles, and you associate them through attachment. So you have attached policies now, in addition to the older inline policies, which allows you to have permutations for very fine-grained access. Moreover, in the managed policy space, you have the concept of AWS managed policies and customer managed policies. So, for example, for security auditors, it used to be where whenever we come out with a new service, you have to go and update your policies to include read access for the auditors or read access for security to be able to describe all the objects and describe the security state of each individual asset. Well, with managed policies, we have a security auditor role that we keep up to date, and you can associate that policy with a role or group used by security auditors or compliance to be able to get access to the environment, test the quality of controls, but then we keep that policy up to date. So whenever we add a new service or a new API call that's a kind of an auditing or described API, we keep that up to date so you don't have to. And you can have your own customer managed policies too that you can attach to different objects. Another great thing about using managed policies is the ability to version those policies, which you could not do with inline policies. Version policies allow you to have versions, and you can have up to 5 different versions of the policy. So every time you make an access change, you're able to roll that back to a previous version. This should read event logging, not access control. So this is the third area of automation that we intended to address today. So again, ISO requires you to do logging and monitoring. Essentially, it says you will capture events to a certain level of quality. ISO, or rather NIST 853, gets a bit more specific about audit generation, and it says you shall generate audit events with timestamps and who took the particular action, and have quality and integrity around those audit logs. It refers back to another control for the details of what the events must include. But this is very simple with AWS as well. So again, it's about the use of the platform, and you can continue to do the things you're already doing in your portion of shared responsibility, like operating system logs, CentOS log, or Windows event log. You can generate application logs the way you were before, or web logs using your web servers. But when you use the platform, you're able to use CloudTrail, which is an AWS service, to get full request and response audit logging of every single API call that's made against the platform. So for compliance folks, knowing that controls are operating effectively in the world of event logging is critical. So being able to check in one place to know that that's operating effectively is very powerful for a compliance and security professional. So just checking to make sure CloudTrail is turned on in every account, in every region, and going to one place is much, much simpler than trying to get logging working on every device in a data center. So imagine a world where you have routers and switches and racks and things that don't log, as well as storage fabrics and servers and everything else. Trying to get all those in one format into one place is a challenge, and it's complex and difficult. CloudTrail eliminates that difficulty by having one place where you can have every single API call that's made. Again, that's every firewall change, router change, subnet change, storage change, anything that's platform-based, all goes in one format with the complete details of the request and the response. And you're able to build complex or simple or complex rules around those. So let's say I want to know every time somebody changes a subnet to change the routing table on that subnet, which from a security perspective is very important. It means that someone can maybe get to the internet previously who couldn't. Or let's say I want to know anytime somebody changes a security group, which is the equivalent of a firewall rule. Those you can set up filters in CloudWatch logs, or you can send your CloudTrail logs to some other thing like a SIM and build filters on top of those to alert you anytime critical security actions take place via the API or via the management console or command line tools, which is quite powerful. And then being able to roll that up into a compliance attestation. So if you're trying to prove to your own customers that or yourselves that you're properly auditing and monitoring events, then simply turning on CloudTrail gives you a long way there without having to do a lot of integration work into your compliance framework. So evidence measuring reality. What I mean is that in typical compliance work papers and compliance cycles, maybe you do a quarterly audit, maybe you do an annual audit, maybe some controls are looked at in detail, only infrequently. One of the core reasons for that is that a lot of it requires just manual processes to go gather all the evidence. And the benefit of using AWS is that you're able to do that in an automated way. So taking the time to invest a little bit of time in scripting or turning on controls that are automated and having logs go in one place, or having good solid practices around how you manage identity, for example, or tagging your instances, being able to validate that those controls are working is quite a bit simpler. And then once you've got those things set up, the idea is to automate those controls so that you're not having to go gather evidence every single time. And then the key thing is once you've put those controls in place, detecting when those controls change means that you know they're operating effectively. AWS Config was launched last year at reInvent, and it allows you to look at all of the assets and relationships among them so that you're able to see time series changes to those assets. AWS Config allows you to, say, take a VPC, for example, and enter that VPC ID into the config console, and then over time see all of the changes. So if someone added a subnet, if someone changed one or more attributes of a VPC, you would see that in a time series way, which is pretty powerful for security practitioners, not only IT folks who can roll things back and see what changed if there's an outage, but the security people can say, okay, this control has changed, or this control is no longer operating effectively because these particular attributes of a VPC or an instance have changed. Great. So I think this is kind of a shorter webinar today.